Hello. Today I'm going to be showing you what is, in my opinion, one of the most underrated ACT math skills, and that is factoring. And I think if you master this skill, you will get 3 or 4, up to even 5, just free points on every single test. And I see so many students missing out on this just because they haven't mastered this skill. So today I'm going to walk you through all the factoring basics and everything you need to know, everything you need to look for, the patterns that are typically on the ACT, and hopefully after watching this video and doing some practice on your own, you'll be able to just pick up 3 or 4 extra points on every single test. Okay, now let's just go through some factoring basics. Okay, so now perhaps the most classic example of factoring is like right here, where it's the 3-term polynomial. Okay, and with the form x squared plus a coefficient with x, and then just a plain constant for the third term. Okay, so the basic form, and I'm sure you heard this, is you're going to get a form of 2 sets of parentheses, both of the first ones starting with x, and then these 2 numbers, the one that goes right here, those goes right there, they're going to add to get this coefficient, and then multiply to get this. Okay, so in this case, do you see it? And the first step to look for it is to look at the factors of this number right here. So what it's going to be is going to be 3 and 4, because 3 times 4 equals 12, 3 plus 4 equals 7. So this is going to be x plus 3, x plus 4. You can fact check this by foiling it. I won't go through that, but there you go. This is the most simple form of factoring a polynomial, where it is just in the form there's no coefficient in front of this x squared, and then you just look for what adds to get this and multiplies to get this. Okay, yeah. Now for the next form that is very common on the ACT is this form of it's something squared and another thing squared, and it's the difference of those two. So it's in the form a squared minus b squared. Right? Because 9 is it is a square. It's 3 squared, right? So a squared minus b squared will always equal a plus b, and then a minus b. That is just a general formula for this difference of squares. Okay, get very familiar with this, because that's just such a handy trick and just a shortcut to factoring this type of thing. So this is going to be, in this case, a in this case is x, b in this case is 3, because it's 3 squared. So it's going to be very simple, just x plus 3, x minus 3. Simple enough. Now for the next one, we got one where it's we do not have just this plain x squared in front. Now we have a 3 out front. And this one's fairly simple, because we know that the 2 x terms at the beginning are going to have to multiply to get 3x squared. So we know that one of these is going to have is going to be a 1x or just x, and the other one has to be 3x, right? So I'll say this is a slightly more difficult one, where you have to do a little bit of deeper reasoning in your mind to get this. But now what I want you to do is just go through the possible factors for this number right here. That's how you're going to find this one and this one, because there's no x with it. So it's only the constants is what's going to determine what these are going to be. So your only options are 3, 2, 6, and 1. It's either going to be 3 and 2 or it's 6 and 1. Right off the bat, 9 times out of 10, it's not going to be the number and it's and 1. 9 times out of 10, sometimes it is like that. I always just like to try these first, 3 and 2. So let's see, can we go x plus 3, x plus 2? Let's just see, x plus 3, x plus 2. So this gives us 3x squared. That's good. And now this gives us plus 9x, and then this gives us plus 6, and then outer, that gives us plus 2x. I think that works, right? 3x squared plus 11x plus 6. Yep, there you go. So sometimes you won't get it right the first try. Sometimes I might have tried x plus 2 and then x plus 3. That wouldn't have worked. So yeah, again, sometimes it doesn't work out perfectly. You got to try it again, but that case we kind of got lucky. Okay, so now on this one, we've got a 2x squared minus 8x plus 8. Now, instantly, is there something that jumps out at you as a common factor in all three of these terms? Because that always makes this far easier. And I see you can factor out a 2 here, you can factor out a 2 here, and you can factor out a 2 here. So we're just going to pull this 2 out front. So 2x squared minus 4x plus 4. Okay? And just like that, it's far simpler to see what adds to get this and multiplies to get this. I see whenever you see the middle number being a negative and the final number being a positive, that means that both of these sets of parentheses are going to have a minus sign. Because if they add to get a negative number but multiply to get a positive number, if they add to get a negative number, that means there has to be at least one negative number, because it can't add to get a negative number if it's only positive numbers. And if there's at least one negative number and you multiply them, then you get a positive number, that means they're both negative, because a negative times negative equals positive. So just using that logic right there, if you ever see a negative followed by a positive in a polynomial, you know that both terms are going to have a negative in them. Now, because we got rid of this 2, now this x is just going to be nice. It's just going to be x and x. And then now for the final term, what negative number multiplies to get 4 and adds to get negative 4? That's just going to be negative 2, negative 2. So there you go. All right, so now for these two, I want you to try and do these on your own. See if you can solve them. They are using techniques that we just did up here. I'll give you a minute, pause the video, try and figure this out on your own. Okay, so now for this one, it's going to be something very similar to this one right here, where we can factor out something at the very beginning. There's an x in all three of these terms that we can factor out. So it's going to be x squared minus x minus 6. This x just stays out front. Oh, and my bad. On this case, I actually forgot this too. Sorry about that. So now this is just going to equal what adds to get negative 1 and multiplies to get negative 6. I think that is x, and oops, let me not forget that x out front. Let me write that better, actually. So it's going to be x minus 3, x plus 2. Okay. Again, simple enough. You just you need to be able to see to factor out that x in the beginning. Now for this next one, 4x squared minus 25. Now this one is a little tricky, because at first you go, okay, it's only 2 terms. It's not immediately apparent to do any of these, because this doesn't really look like 2 squares. There's not really anything we can pull out. But I want you to look closer at it and look at this first term. Is this a square? And you might say no, because it's got that number out front. But look, 2x times 2x equals 4x squared. So it actually is a square, even though it's got that coefficient out front. And that's a super common mistake I see, is just people not thinking that this is a square, because it has that coefficient out front. So that's one thing that it will do you very well if you can notice that. So now do you see the factorization of this? It's the same form as up here, the a squared minus b squared. If you haven't got it already, try it one last second. And okay, it's going to be 2x plus 5 and 2x minus 5. There you go. Okay, so these are all the general, the basic types of factoring. You really probably won't need anything much more difficult than this. There are a few smaller, like, little types that I'll show you in a minute here, but if you can master all of these right here, I guarantee you're going to get at least 2 or 3 more points on every single ACT. So, okay, now for the other problems. We'll do these 2 right here, because these are times where the factoring actually becomes useful. Okay, so like in this case, it might be a question like simplify this. So to simplify this, there's nothing immediately apparent, but if we look up top, we got this x squared minus 9, which we can factor this. So we could factor this and say that it's x plus 3 and x minus 3. And on the bottom it's x plus 3. Okay, so now look, we got the same term on top, same term on bottom. These two are just going to cancel out. So this whole thing is just going to equal x minus 3. So like that right there, there you go. That's a very plausible question for there to be to simplify this. Maybe in the first 20 questions, but we'll get to more complex ones later. But yeah, and then same thing with this case. You might get a question asking to simplify this right here. So let's see it. Do you see the factorization of this? I see it as there's a 3x in both this term and this term, and actually in this term too. So you go 3x, and then it's going to be just an x plus 4 over 6x. But remember, there is a 3x times 2 equals 6x. So what we could do is we could write this as 3x times 2 instead. So now, same thing. You can cancel these out. Now, this just equals x plus 4 over 2. There you go. These are two examples where you get something like asking to simplify it, and the factoring makes it just, I mean, that's the only way you're able to do it. Okay, now here's an ACT actual practice problem. One of the more difficult questions. This is in the last 15 questions. So this one, it's tricky. You look here, there's 3 different types of variables. You're thinking, okay, what in the world? Like, I mean, a lot of students will see this and just be like, oh, I don't know how to do this. But I just want to show you that it is not, you really just need to just see what you're looking for, okay? So immediately, one thing I notice is that this term right here is very similar to this term right here. The only difference is this one has a 2, and this one does not have a squared right here on this x, but this one does. Okay, so knowing that, what am I going to try and do? I'm going to try and get rid of this squared, and I'm going to try and get rid of this 2, and then maybe we'll be able to factor this out somehow. I don't know. I can't tell yet. But the first order of business is we're just going to factor out an x from the top, because look, there's an x in all 3 of these terms. We can factor this out. So it's going to be equal. We're just going to factor out an x on the top, and then on the bottom we can go ahead and factor out a 2. That seems like that's the easiest thing. So this would just be 2 minus 2, and then minus 9. So factor x on top and 2 on the bottom. Write this out. This is going to be 12 minus 3 minus z cubed x y squared. Only x because we factor out an x there. And then on the bottom, it's going to be z cubed x y squared minus 9. Okay, so now we see we can probably combine these two terms right here. So we're going to do just that. We're going to combine these two. And this is just going to be a 9. So now we got, you say, okay, well, this looks really similar, but they're not the same. This is 9 minus this, and this one is this minus 9. Now let me ask you, is there a way we can factor out, or not factor out, but is there any way we can change these signs? And I am here to tell you that actually, yes, there is. There is a way to change these signs, because what you can do is you can pull out a negative from this. You could pull out a -1 from this. You can factor out a -1, and what it does is it flips both of these signs. So that's a little trick that is very useful, and you wouldn't be able to solve this problem if you don't have that trick right there. So if you ever have a case where you need to change the sign of both of these, because remember in this case it's a -9, in this case it's a positive z cubed, whatever. This one's a negative z cubed, and this one's a positive 9. If you need to flip signs of both of these, you can pull out a -1 and multiply everything on the bottom in the parentheses by a negative. Okay, and just like that, you might not see it immediately, but these are actually the exact same term. If you want, you can flip them around to make it, I might do that just so it's more clear. But these are now the same term. So now you get the same term on top, same term on bottom. Those just cancel out. And all of a sudden, you're just left with -x over 2. And is that an answer? Yes, it is. So in this case, it really is it looks so daunting at first right here. But if you just see, just very basic factoring there. It was just factoring out an x, factoring out a 2, and the only tricky step was knowing to pull out that -1. But if you can start seeing stuff like that, you'll start getting way more questions right. Now, this is, on a practice test online, this is the first question. Literally the first question is what is the complete factorization of the expression x squared minus 16. We just learned this. It's the difference of two squares, two things that are squares, which is going to be. And you should be able to see this just like instantly. It's C. You don't even have to do it, because we know that a squared minus b squared equals a plus b, a minus b, and that's what we got right there. So yeah, that one right there, super easy. I mean, it's the first question on one of these practice tests, so I mean, that's very well. I mean, there's almost always a question like this in the first 10 or 20. Now, I mean, look at this. Later on, same practice test. This problem, and these two problems are all in the same practice test. Like I said, 3 or 4 questions like this on every single test. So, here we go. So, in this case, Dina found that x squared over 4 minus 4x plus 16 represents the area of a square, which expression represents a side of the square. So, all this is going to be is just a, you're just factoring out the same term, because when it says that this is a area of a square, it means that the square root of this will equal one side. So I mean, if you draw this out, the area equals x squared over 4 minus 4x plus 16. So one of the sides equals x squared over 4 minus 4x plus 16, right? So, and the way we could solve this is just by factoring, and we're gonna get the same term twice. So just by factoring this, what needs to multiply to get this? I think that's gonna be x over 2. X over 2 times x over 2 equals x squared over 4. And then for the second term, this is gonna be, it's gotta be, this thing's gotta multiply to get to get positive 16. Which sounds to me like this is going to be a negative 4 twice. So it's going to be x2 minus 4. So let's check this answer. We multiply the first term, we get x squared over 4. Multiply the second term, we get minus 4x over 2. Multiply the outer term, we get another minus 4x over 2. And then final term, plus 16. We add these two together, you get negative 8x over 2, which equals 4x. And boom, there's your answer. Just like that factoring right there. It'll give you the same term twice, but again, that is factoring. And yeah, so this is going to be an answer right there, one of these. X squared minus 4. There you go. Now for this last one, try to do it on your own. Okay. Again, a lot of these questions is not like, they won't be as simple or as straight up as like, oh, just simplify this, or just what is the complete factorization of this. A lot of times it's, the factorization is a tool you have to use, like in this case, and also in this case. So this just says solve the equation. So try and do it on your own. Okay. So way I'm going to solve this is, first off, getting 4 to this other side so we can get it equal to 0. So it's going to be 0 equals 12x squared minus 2x minus 4, because we subtracted this 4 to the other side. Now, we just got to factor this. So, do we see anything that we can pull out at the very beginning? I see a 2. So, we can factor out a 2. 6x squared minus x minus 2. Okay, so now we got this. This is kind of difficult because on this first one, we've got a 6x squared. So we don't know if this is going to be, we got 4 possible solutions for this first term. This could either be 2x, 3x, 1x, or 6x, because it's going to be, these first two terms are going to multiply to get 6x squared. And okay, so we see it has to be one of these 4 right here, and I just take a quick glance at these answers, and I see a lot of 3s in here, a lot of 2/3, a lot of 1/2. So I mean, just by seeing that, I don't see any 1/6 or anything. So I mean, I can see that this is probably going to be, it's probably going to be these two. Okay, that's just a test taking strategy. Look at the answers, it's multiple choice, so it makes it easy. So we'll go 3x on one of these, and then we'll go 2x on the other one. Okay. So now we just got to figure out what these last terms are going to be. And we know they need to multiply to get -2. So one of them is going to be a positive, one of them is going to be a negative. So we just need to figure this out. So let's do some trial and error. For this first one, we'll try -2 plus 1. So first terms, we get 6x squared. That's right. Outer, we get 3x. Inner, we get -4x. Oh, it's looking good. And then last, we get -2. Add these two together, we get -x. And look at that. I believe that is our answer. So now we know the correct factorization, which is this. But remember, this equals 0. So remember, to find the answer to this, we just need to set each one of these terms equal to 0, because if one of them multiplies to get 0, or if one of them equals 0, the whole thing equals 0. So we got to set each one equal to 0. So 3x minus 2 equals 0, and then 2x plus 1 equals 0. So on both of these, we're just going to get the constant to the other side. So 3x equals 2. Divide both sides by 3. X equals 2/3. And in this case, we're going to subtract it to the other side, and we'll flip it around here. -1 equals 2x. Subtract 2, -1/2 equals x. There's our answers. Got x equals 2/3, -1/2 equals x. Now let's see, is there any of them that line up with this? Positive 2/3 and -1/2. I think that looks like B to me. All right. Thanks for watching. I hope that this helps you. And again, just find some practice factoring problems online. Work on this, and I promise you will get at least 3 or 4 just free points each test if you have mastered these skills. So thank you so much for watching. Have a great day, and follow me for anything else test prep, anything else math. Thank you.